Jai Hind all. The topic which we are going to discuss is grid computing. Basically, I have chosen this topic because we have seen what is cloud computing, what is clustering. So sometimes the question comes, what is grid computing and how it is different from cloud computing concept. So I took this particular topic, grid computing. It's a particularly introductory slides. These are my introductory slides. So we are going to see what is grid computing, what are the grid topologies, methods of grid computing and grid architecture. So what is grid computing? When we say a grid computing, it is a type of a distributed computing. We have seen in unit 1 what is distributed computing. So grid computing is nothing, it is a, you could say it is a branch of a distributed computing where we are using super and virtual computers and we are making a cluster of them, a network of those computers. These computers, they are loosely coupled computers acting in concert to form a very large task. So what are the things? First, distributed computing, then comes clustering. Now these clusters, they comprised of loosely coupled systems. There are many definitions of grid computing, but in 1999, Foster and Kesselman, they defined the grid computing, that it is a growing technology that facilitates the execution of large-scale resource-intensive applications which require large computation power, maybe they require large storage facility on geographically distributed computing resources, that is the systems on which we are doing calculations, we are storing the data, they are geographically distributed throughout the world. We are not aware where the exactly our computation is going on in a real time. It facilitates flexible, secure, coordinated, large-scale resource sharing among dynamic collections of individuals, institute and resources. It enables the communities. These communities, they form the virtual organization to share geographically distributed resources. And what is the basis? They are forming the community, that is a common goal. Criteria for a grid: the coordinates resources that are not subject to centralized control, that is they uses standard open general purpose protocols and interfaces when they are forming a virtual community, delivers non-trivial qualities of services. This is a simple grid system, you could say. So these are the various systems. On some systems we are doing computations, on some system we are storing the data and we are interacting. These systems, they are interacting among themselves. They are autonomous, that is acting on their own, may be present at any place in the world, and basically they are forming a cluster. Now the question comes, when we are having a distributed concept already available with us, then why we are going with the grids? Because many large scale problems, they cannot be solved by a single computer. At that time we need to form a network of systems where, because these large scale problems, they are uses a large scale of resources, they are very resource intensive, which cannot be satisfied by a single system. May be possible to solve them, we require a group of systems which are working in a collaboration with each other to solve that same problem. Another, globally distributed data and resources. So we need to have a system where we can combine these globally distributed data and provide a unified view to the user, where the user will do the run a problem or may store the data. So on the basis of this, what are the benefits we are getting? It exploit underutilized resources. Maybe at some places we are having those systems available with us, maybe space is available or they are free, they are not doing any intensive calculation. So we can identify such kind of resources if they are present in our cluster, and we can assign the task to these systems. Resource load balancing. We can go with the load balancing so that each and every node in our distributed system or in our grid will get equal task to compute. Virtualize the resources across an enterprise, and when we virtualize the resources across an enterprise, we came across with data grids and we came across with compute grids. It enables the collaboration for virtual organizations. What are the technologies behind the grid computing? The very first is cluster computing, then peer-to-peer and internet. What is cluster? We have already seen what is a cluster, so it is just a recap. So what is the idea behind the cluster computing? Put some pieces together and get them to communicate with each other. They are cheaper to build than a mainframe supercomputers because we require to solve the large resource intensive or the computation intensive application. So they require the capacity which is equivalent to a mainframe supercomputers. Then in that case we don't need to worry about it, how that what is the cost of such systems. Then in that case the grid computer system, it form a cheaper solution, it provide a cheaper solution to the users. Different size of clusters, as our requirement we can form the clusters. Scalable, can grow a cluster by adding more PCs. So this is a simple cluster. Here you could say input data is coming, one of the my system is root node where the input data is coming. Here the main calculations and all these things are going on and the result is produced to the user. Now this particular root node, it is distributing the work to the slave node, and some of the computation may be going on this, another may be going on this and this. So in this form the clusters, they solve a problem. Peer-to-peer, here all the systems, they are connected to each other. Can access the files from any computer on the network. It allows the data sharing without going through the central server. Decentralized approach, also useful for grid. That is, all the systems, they are connected with one another. If this system requires the data from this system or some calculation or want to run a code on this system, then it can directly interact with this system. Internet, as we are aware that all the PCs nowadays, they are connected on the internet, so they can perform other computations while not being used. Cycle scavenging, that is rely on getting free time on other people computers. Example, we are aware what is a internet computing. Now come on the different grid applications. We are having data and computationally intensive applications, that is, these are the applications which require the grid computation. So this technology has been applied to computationally intensive scientific, where the lot of computation need to be done. And what are such applications? We are having scientific applications, complex mathematical problems, or the academic problems. For example, your drug discovery, economic forecasting, seismic analysis, weather forecasting, etc., etc. So maybe a chemist, for example, a chemist may utilize hundreds of processors to screen thousands of compounds per hour. Teams of engineers worldwide pool resources to analyze terabytes of structural data. Meteorologists, they seek the visualization and analyzation which is in on the data which is in petabytes, and this is your climate data with enormous computational demand. So in this case, since a lot of organization, they are coming together in this case, maybe our data is distributed at different states or different locations, then we need a grid here because a lot of computation need to be done. Resource sharing, That is, these are the applications we want to share, where we are not going for the computation, but we are just sharing the resources. Now these resources, they may be my systems, storage, sensors, or networks. Sharing is always conditional. That is, it should be, why we are saying the sharing is conditional, because there is a issue of a trust. Maybe some policy is hindering while sharing the resources. Negotiation need to be done. What is going to be the payment mode, how much payment need to be done. So a lot of constraints comes here when we go with the resource sharing. Coordinated problem solving, for example, we are going with the distributed data analysis, computation, or some collaboration. For example, in a drug discovery, maybe very few of the pharmaceutical companies, they have come up together to provide a solution. Now come on the next topic, that is grid topologies. When we talk about the grid topologies, we are having three types. One is intragrid, then extragrid, and the intergrid. What is intragrid? It is a local grid within an organization. That is, when we form a grid, a cluster of systems within an organization, then it is your intragrid. Trust based on personal contracts, because it is within the organization. So here the trust factor, it is based on the trust among the employees. Extragrid, here the resources of a consortium of organizations connected through a virtual private network. That is, a group of organizations, they come up together, they form a consortium, and this consortium is sharing a grid. Here, how the trust is built up, it is based on business to business contracts. The last one is intergrid. It is global sharing of resources through the internet. That is, anyone with similar interest, they can come together and join the grid. Here the trust is based on the certification. That is, the administrator, the persons who are looking after the grid, the maintenance of grid and other aspects of the grid, from that organization, you need to take the certification. Once you got a certification from those organizations, then you can join the grid. We have come across in previous slides two terms. One is computational grid and another one is data grid. Now let's see what is a computational grid. So a computational grid, it is a hardware and software infrastructure that provides dependable, consistent, pervasive, and inexpensive access to high-end computation capabilities. That is, we are using the computation resources, and the paper is, there is the grid blueprint for a new computing infrastructure. It is published by Kesselman and Foster. The example of computation grid, for example, Science Grid, which is hosted by US Department of Energy. In the data grid, what we are doing, it is a grid computing system that deals with data only. That is, we are storing the data here. The control, sharing, and the management of large amount of distributed data. The data grid, it is a storage component of a grid environment. Scientific and engineering applications require access to a large amount of data, as we have seen in the medical field. We are having the genomics data and all these things. So, and often this data is widely distributed. A data grid provides seamless access to the local or remote data required to complete the compute-intensive calculations. For example, Biomedical Informatic Research Network, the Southern California Earthquake Center. So these are the examples where we require the data grid. Now come on the next heading, that is, what are the methods of grid computing? These are the 5 methods of the grid computing. The very first one is distributed supercomputing. What it says? The idea behind this is aggregate computational resources to tackle the problems that cannot be solved by a single system. For example, when we are going for the climate modeling, computational chemistry, so these applications, they require a huge computation. They are very computation extensive applications. So Here the model which we are going to use, it is the distributed supercomputing. What are the challenges need to be addressed here? Schedule scarce and expensive resources, scalability of the protocols and algorithms, maintaining high levels of performance across heterogeneous systems. So these are the main challenges when we adopt this model. High throughput computing, the idea is to exploit unused CPU cycles, that is from idle workstations. So what we do here, schedule the large number of independent tasks. Unlike distributed computing, task is loosely coupled. For example, when we are having parameter studies or cryptographic problems, then in that case, the grid, we use the high throughput computing model. On-demand computing, here we use the grid capabilities to meet short-term requirement for resources that cannot conveniently be located locally, that is, they cannot be hosted locally. Then in that case, they are globally present, but the requirement is short-term. Unlike distributed computing, driven by cost performance concerns rather than absolute performance. Here we dispatch expensive or specialized computations to remote servers. Why? Because here the main focus in cost versus performance. Data intensive computing, here we synthesize the data in geographically distributed repositories. Synthesis may be computationally and communication intensive in this case. For example, high energy physics generate terabytes of distributed data, need complex queries to detect interesting events, or distributed analysis of slow and digital sky survey data. So these are the examples of data intensive computing. Another and the last one is collaborative computing. It says, here we enable shared use of data archives and simulations. Example, collaborative exploration of large geophysical data sets. Challenges are real-time demand of interactive applications, because here the geophysical data sets, so no doubt the applications which are using or working on this data sets, they are going to be, they are real-time applications. Moreover, we are having a rich variety of interactions. This is a typical view of grid environment. Here we are having the grid information service. Then this is my resource broker, and we are having here grid resources, and this is the user. So the details of the grid resources, whatever be my resources, they are present at the grid information service. So what the grid information service does, this system collects the details of the available grid resources and passes the information to the resource broker. That is, it will pass the information to this. This is my resource broker. Now, what the resource broker do? It distributed the jobs in an application to the grid resource based on the user's QoS requirement, that is quality of service requirement, and details of available grid resources for further execution. It sent all the details, available resources to this broker. Now the user, it will send the request, that is its grid application request to the broker. Now this broker will identify what are the systems to which the resources are to be allocated, and these grid resources, they may be located geographically anywhere. It will assign the computational jobs, they will execute the jobs. Once the processed jobs, they will send the result, it will aggregate the results and send the computation result back to the user. So grid resources, they can be my clusters, my PCs, my supercomputer, instruments, database. In the global grid, execute the user jobs. And what the user is doing, he is just sending the computation or the data intensive application to the global grids in order to speed up the execution of the application. So this is a typical grid environment. That is how the things are going on in this area. Grid middleware, how we form the grid. For the forming of a grid, we need a middleware, and We call it gridware. It is a special type of middleware, that is, it is a software that enables sharing and manage grid components based on user requirement and resource attributes. What are the resource attributes? If it is a store data, then it is going to be the capacity. If it is a computation grid, then the performance, it plays an important role. It is a software that connects other software components or applications to provide the following actions. That is, it runs the applications on suitable available resources, for example, your broker, your scheduling. It provides uniform high-level access to resources, maybe through semantic interfaces or web service or SOA, or adopt the SOA, that is service-oriented architecture. It addresses inter-domain issues of how the security, policy, etc. because here the systems involved, they are having the federated identities. It provides the application level status, monitoring and control of the grid. So these are the responsibilities of the gridware. These are the few examples of middlewares. For example, Globus, it was introduced by Chicago. Condor, it is basically use the model high throughput computing. Legion, given by the Virginia University, it provide virtual workspaces meant for, and it uses the collaborative computing model. IBP, that is internet backplane, this particular grid is provided by Tennessee University, and it is based on logistical networking. NetSolve, it is basically designed for solving scientific problems in heterogeneous environment, and the model here is high throughput and data intensive models. This is a layered grid architecture corresponding to internet protocol architecture. So here we are having a link layer, then we are having transport internet layer and the application layer. Corresponding to these layers in the grid, at the equivalent to the link layer, we are having the layer fabric. In transport and internet, this facility, both these layers, we are corresponding to this, we are having the connectivity, and the application, it has been divided into resource, collective, and on the top we are having the application layer. So basically what the fabric layer does, it control the things locally, that is access to and control of the resources, all the controlling part, resource, how you allocate the resources, all these things is handled by the fabric layer. What the connectivity layer does, it is basically responsible for talking to things, that is my devices. So communication, here we use internet protocols as well as security part is also handled on the connectivity layer. Resource layer, basically responsible for sharing single resources, that is how we are negotiating the access, controlling the usage, and all these parameters, they are being handled here. On the collective layer, we are having coordinating multiple resources, single resource collaboration done on resource layer. On multiple resources, we are having the collective layer, and here we are having ubiquitous infrastructure services, app specific distributed services, and so on. So once you give some command to a grid application, then it passes the things to collective, resource, and the connectivity layer, and how we physically allocate the resources, this is done by my fabric layer, that is controlling the things locally, how we are going to access them, it is being controlled by the fabric layer. So this is the layered grid architecture. These are the few business areas where we deploy the grid. It is your life sciences, financial analysis, in the research field, in engineering and design field, collaborative games, and government also uses the grid for its functioning. These are the few simulation tools. GridSim, basically for doing job scheduling. SimGrid, single client multi-server scheduling, bricks for scheduling, then OptoSim data grid simulations, G3S, it is a grid security service simulator basically for security services. These are the simulation tools which provide a grid environment. These are the resources from where I prepared these slides. So this is all about grid computing, an introduction to grid computing. Thank you and Jai Hind.